Good morning, guys. Welcome here to my session. The aim for today is to explore the synergies between the cloud native world and the AI world. So let's start. My name is Graziano. I am a DevRel engineer at Mia Platform, an Italian company that develops a platform builder that, among other things, simplify the adoption of the technology we will be discussing today. This talk actually comes from a conversation I had a few months ago with a close friend of mine, Leonardo, who works as a data scientist and deals with model and data every day. One evening, after a slight alcoholic aperitif, what do you think two engineers will talk about? Work, of course. So Leonardo begins explaining all the problem he faces in his daily work. He started with this sentence: when everything seems to be going smoothly, something always going wrong. And then he adds, it takes longer to put the model into production than to develop it. And as I found out later, he is not the only one with this problem, as you can see from this screenshot from this tweet. So guys, I am not an expert of this kind of stuff, but I'm extremely curious, so I asked him to explain his workflow. He immediately starts talking about feature management and inference, and I'm like, inference? What? Give me the beginner version, please. So he simplifies as much as possible, explaining that the workflow follows 4 steps, as you can see on the slide. The data preparation, which is the preliminary phase where the datasets are prepared. The model training and the tuning, where the model is actually developed, and then when the deployment and monitoring is the phase, which is when the model is put on production and its behavior is monitored and finally the process is repeated and improved the model. As I soon learned, none of this step is free from issues. The first problem Leo points out is dealing with the data. Managing large volumes of data without a clear governance is a huge challenge. Tracing the history or lineage of the dataset, identifying the data owners, and understand the data sensitivity, it's all a nightmare for him. Then there is the gap between the local development and the production release of the model, which is actually the most important trouble for Leonardo. He explains that when he do his magic on its local Jupyter notebook, everything works fine and runs perfectly. But then when it's taken by the delivery team, it's entering in a whole new world. The last one is the observability nightmare. When they survive the production release, monitoring the model behavior to spot issue as early as possible become a challenging task, and they often don't have a sense of full control over what's happening, risking to being too late in resolving critical issues. The conversation ended with Leonardo feeling frustrated and me headed to home still thinking about what Leonardo said, and the question that arises in my mind is, how can I apply my expertise to help a friend of mine? In my mind, I had somewhat like a meme, with the VOPs on one side feeling frustrated thinking at the models and excited thinking at the infrastructure stuff, and on the other side, the data scientists excited of their models and frustrated thinking at the deployment activities. However, this situation wasn't new to me. This is exactly how operation guys and developer felt years ago before the introduction of the DevOps culture. So, here are my intuition. How can I apply my knowledge about the application development, DevOps, and cloud native world to solve the issues that are actually similar to those we faced in our context some years ago? Spoiler, the answer is yes, of course, but let's see together how. First, we need tools. And fortunately, the Cloud Native Computing Foundation and specifically the AI Working Group made an excellent work mapping all the tools in the cloud native landscape that could help the ML world creating the cloud native AI landscape. Adding tools alone into the delivery chain risks to add just a lot of complexity, actually increasing the issues. Then we need the methodology, a framework to govern all these tools and make their adoption simple and seamless. This methodology is actually the platform engineering. Thanks to the platform, provide a place between engineers and their dependency, helping them to consume what they need in an easy and self-service way. The first problem pointed by Leonardo is dealing with data. And that's actually not a problem related with tools, but is a problem of culture. The lack of data governance is a clear reflection of the lack of a proper data culture inside the company. I suggest to start cultivating a data culture inside the organization by adding some tools that could help during the process. The key point here is to understand that the AI is as effective as the data used to train it. A model fed with poor quality or inaccurate data will produce poor results. A tool that simplifies all these activities when dealing with data, like discovering, profiling, versioning, tracing, is essential to ensure high quality and consistent data being used and produced. The tool we are talking about is a data catalog, which is essentially a hierarchical archive of all the metadata of your data sources. A data catalog contains all the technical metadata like data type, storage location, and the lineage, which explain how the dataset are connected to each other, and also the business metadata like ownership or compliance level to specific regulation. Since with data catalog, all the information about our dataset are centralized, making them easily searched and well organized, it's the Swiss knife for everyone who need to deal with data inside the organization. Now it's time to deal with the main issue pointed out by Leonardo. So we have to understand how to bridge the gap between the local development and the production release of the model. This way, many tools from the cloud-native AI landscape could help us. One of them is Kubeflow. The problem here is due to the fact that on one side, we have the data scientists who work in their environment, like PyTorch, Jupyter Notebook, and something else. On the other side, we have the DevOps guys, which are to deal with the completely different environment. And it's this opposition of ecosystem, the core of the problem. So to solve this challenge, we need to bridge the gap between these two ecosystems. This bridge is Kubeflow, a collection of open source projects designed to support each stage of the machine learning lifecycle, bringing the ML on Kubernetes in a simple, portable, and scalable way. In this way, we bring the world of the data scientists inside something that delivery teams know well, the containers and the Kubernetes. The first project I want to discuss about is Kubeflow notebooks. The core problem underlined by Leonardo is the gap between developing his model locally during the experimentation phase and then moving them into production. This is because development happens in a completely different environment from production, and producing all the development conditions could be a huge challenge for them. Kubeflow Notebook helps solving this issue by providing a way to run web-based development environment inside a Kubernetes cluster. This notebook actually runs as a container inside the Kubernetes pods, so that user can create their notebook directly inside the cluster rather than locally, and admins can provide standard notebooks image for their organization, with the required packages installed, for example. Working in this way, data scientists develop the model in a standardized way that DevOps engineer can then understand and replicate over the production environment, since both phases actually happens in the same environment, which is Kubernetes itself. Another major challenge in this context is managing distributed training, and Kubeflow helps simplifying these activities, providing the Kubeflow training operator, which is a Kubernetes operator for fine-tuning and scalable distributed training of the ML model. It works by implementing a central Kubernetes controller that coordinates distributed training jobs, supporting also high-performance computing tasks. The training operator allows to scale the model training from a single machine to a larger distributed Kubernetes cluster by using its APIs and interface. Another important use case to cover is the case in which we just want to create AI-powered product or to add AI-powered feature to our existing product without developing the model, but using a third-party models like GPT, Mistral, or Llama. In this situation, our application has to handle various aspects, including request, authentication, authorization for accessing the model, for example, prompt management, caching, and spending check with the AI provider. This approach not only adds complexity to our application with tasks outside the core function, but also makes switching between models challenging, and it couples the application to the specific model. The solution to the problem is to use an AI gateway. Similar to common API gateway, an AI gateway is a middleware between the application and the model, managing their interaction. By introducing an AI gateway, we can centralize and delegate tasks like model authentication authorization, prompt management, caching, and spending check. This way, these responsibilities are handled by the AI gateway, not within the application itself, reducing the coupling between the application and the model. This setup also makes it easy to switch to a different model or even use multiple models based on specific needs. The last issue involves model monitoring. My suggestion here is to use some of the best practices already in use in the cloud native world with few adjustments to adapt them to the specific need of the model monitoring. Monitoring a model is essential to identify and solve issues before it's too late, but identifying what to monitor is the key. The most immediate metrics to collect are the operational metrics like CPU or RAM usage that indicates if the system is working properly. But it's not enough in the space of model monitoring. We need also to take a look at inputs that the model received to be sure it received the right data in the right form to perform prediction efficiently, and the outputs of the model to evaluate its performance. All this attention is needed to spot eventual drift that could happen in our system. In this context, the drifts refer to any changes that could impact the model accuracy. And that can be essentially of three types: data drift, prediction drift, and concept drift. In simple terms, data drift occurs when the statistical properties of input data changes, leading to decreasing accuracy even if the model itself don't change. Prediction drift instead refers to prediction changes even if the data doesn't change due to the model itself or to external factor. Then concept drift refers to changes in the relationship between the input data and the target variable affecting the pattern that the model has learned. To keep track of all these aspects, we can use two open source software: Prometheus, which is a monitoring toolkit to collect real-time metrics in a time series database, and Grafana, which offer an extensive option for dashboard creation and data visualization, completing Prometheus, allowing us to visualize the connected metrics. Prometheus and Grafana together offer many benefits in the realm of monitoring ML system. In fact, they allow us to collect a wide range of metrics, from the system performance to the specific model in customizable way and a real-time way, offering also the possibility to set up alerts on specific events or thresholds. Both are designed to handle large-scale data, providing a highly flexible system for model monitoring even when the complexity grows and the needs change. To wrap up, we discussed about many tools, but just adding tools to the chain only increase the complexity of the system. We don't need just tools, we need a way to adopt them with a self-service approach and with less friction possible. This way is through internal developer platform and platform engineering. By building an internal developer platform that leverages this tool, we can standardize and simplify their adoption while creating power path for common use cases that can be consumed throughout a catalog of resources in a self-service way. Just for reference, if Leonardo needed a development environment to run their experiments, just need to access the catalog and choose the one with the configuration and libraries that best suits his need. The same happens when Leonardo needs a cluster for distributed training, or if delivery teams need to set up the monitoring dashboard for a new services, for example. Analyzing all these factors, a question raised in my mind: could the cloud native world and the application development world benefit from the recent explosion of AI, and if yes, how? I deal with platforms every day, so trying to find an answer to this question, I started thinking to them. Platforms are an heterogeneous set of elements made up of metadata, repositories, pipelines, documentation, and many other assets in various formats. And using a platform today actually means managing all these assets and being able to govern and navigate them. So what if instead of having to work against this asset, we made them work together and allowing us to access them in a unified interface? This is where the conversational DevX comes into play. With conversational DevX, I refer to a way to elevate the use of platform and enhance the DevX of those who use them. It involves the use of a RAG system applied to the platform assets, allowing us to leverage the capabilities of Gen AI to analyze and query the platform assets using natural language. That's not just a vision, it's already available in an early stage version, and I invite you to try it over your own assets by scanning the QR code in the last slide to access the GitHub repo. Imagine a world where you have a virtual assistant that speaks like you, with the added benefits of perfectly understanding the context of your platform because it is actually your platform. Now imagine what you could do with this assistant that know all the models, the lineage, then the pipeline around them. It's now the tool you can use, the best practices for using them, and even how others have used them. Troubleshooting production issues or conducting a proof of concept is such a context is on a whole new level. The presentation is finished, and before saying goodbye, let me recap the key points from the session. First, applying old solution to new problem can be a smart way to solve them without reinventing the wheel. Second, platform are a highly customizable tool that can meet specific needs and can streamline the work even in the realm of MLOps. Finally, I don't know if AI will steal our job in the future, but now it's a powerful tool to enhance the developer experience. Thank you guys. Here is a feedback form where you can leave your feedbacks. See you